Hello students. So in today's class we will discuss the very important chemical reaction from alkanes. So in previous class already we discussed the few reactions. Okay students. So today we will discuss the isomerization. Okay. So you know the isomerization concept. Yes. Isomerization, you know what? So isomerization is nothing but the compound having the same molecular formula but they have the different structural formula. Okay. So that is what isomer, and that phenomena is what isomerization. Now clear students, isomerization is what? The compound having the same molecular formula but different structural formula. Okay, but this isomerization reaction now here we are using in petroleum industry. So this is very useful isomerization reaction. Just see students, so here I have taken the N-butane. Okay, so N-butane CH3 CH2 CH2 CH3. So this N-butane undergoes isomerization in the presence of anhydrous AlCl3. Anhydrous AlCl3 means what? Aluminium chloride. Anhydrous means so there is no water content. Okay, so in presence of hydrochloric acid we just heat. Okay, N-butane when we can heat in presence of AlCl3 and HCl. So what will get students? Simply we get what? Isobutane. Okay, so N-butane is what? Straight chain compounds. So by using this N-butanes we have to prepare the isobutane. Okay, so just see in N-butane how many carbons are present there? So there are 4 carbons. Okay, C4H10. So in isobutane also just take how many carbons? 1, 2, 3, 4. Here also 4 carbon and same hydrogens are there. 10 hydrogens. Now clear students? That means so it have the same molecular formula C4H10, but the structure is what? Different. It is a straight chain, it is a branched chain. Okay, now clear students? So by using the straight chain we can prepare the branched chain alkanes, and this is useful in a petroleum industry. So now we will see the another example students. Here I have taken the N-hexane. So you know the N-hexane, you know, so it have the 6 carbon compounds. So CH3 CH2 4 times, or we can write CH3 CH2 CH2 4 times like this, CH2 CH2 and then CH3. So it is N-hexane. So N-hexane also undergoes isomerization. So in the presence of anhydrous AlCl3, okay, same conditions we have to apply here. We can using the hydrochloric acid and we just heat. Okay students, N-hexane undergoes isomerizations. So students, probably we will get the two kind of the compounds. Okay, two possibility will be there. So one is the we will get the 2-methyl pentane. 2-methyl pentane, same carbon should be there. 6 hexane. Just see in N-hexane how many carbons are there? 6 carbons. So in 2-methyl pentane check how many carbons? 1, 2, 3, 4, 5, and this one 6. Okay, but it is a branched chain alkanes. 2-methyl pentane. You can do the numbering from here. This is the first carbon, this is the second, third, fourth, fifth. Okay, so this is what? 2-methyl pentane. So it has the same molecular formula as like a hexane. Remember students. And another possibility is what? We can form 3-methyl pentane. It have also the same molecular formula. Okay, C6H14. Okay students. So just check it. 3-methyl pentane. 1, 2, 3, 4, 5, 6. Okay, count the carbon, hydrogen atom also same. Okay, 14 hydrogens. So this 3 plus 2 5, then 5 plus 1 6, 7 8 9 10 11, then 3 14. Okay, so that means it have the same molecular formula, but should they have the different structure. Now dear students, N-hexane undergoes isomerization. So it forms the 2-methyl pentane as well as 3-methyl pentane. There are the two possibilities. Okay, now clear students. So important note in there, the process of isomerization has an important use in a petroleum industry for rising the octane number. So this is very important students. So the isomerization concept, it is very important in petroleum industry. Why? So it can increase the octane number. Okay, what is the octane number? Actually, the quality of the petrol always depends upon the octane number. Okay, you remember students, the quality of the petrol depends upon the octane number. Okay, so what is the role of isomerization here? They can increase the octane number. So that's why this isomerization reaction is very useful in petroleum industry. Now clear students, so let me discuss the one more important reaction. So that is what? Aromatization. So aromatization is what? Simply aromatization is nothing but there is a formation of aromatic ring. So aromatic ring means what? aroma means, so actually aroma is a Greek word, you know, already discussed in introduction part. Aroma means pleasant smell. So actually aromatic compound is the compound which containing the benzene ring. Okay, so aromatization is what? There is a formation of aromatic ring is nothing but benzene ring. So it is simple aromatization, we can form the benzene compound. Okay, see here in aromatization, so simply we are taking the N alkanes. Okay, so here I have taken N hexane and straight chain hexane, CH3, CH2 4 times again CH3. Okay, so that means CH2 4 times and this CH3 and CH3 means how many? N hexane. So it undergoes aromatization in presence of chromium trioxide, Cr2O3 and V2O5. What is meant by V2O5? Vanadium pentoxide. This catalyst we are going to be used and we can heat at 773 Kelvin temperature and we can maintain the pressure 10 to 20 atmospheric pressure. So what happens, students, then? So this N-hexane, they converts into the benzene ring. So how many carbons here? 6 carbons. So in benzene ring also 6 carbons. So very simple, students. So benzene ring, you know, they have a so each carbon containing the CH2 group, CH2, 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 CH2. Means obviously what we get? Benzene ring. So it can form the cyclic compound after heating this hexane converting to the benzene ring. Very simple. Now understand, everyone. See, students, one more reaction. So N-heptane, if you heat the N-heptane, same process we are going to do. So if you take the chromium trioxide and vanadium pentoxide, now 7 carbons are there. Heptane is 7 carbons, CH3, CH2 5 times CH3. So obviously, first when we can heat heptane in presence of chromium trioxide and vanadium pentoxide at 773 Kelvin, first of all it form the benzene ring, 6 carbon compound it will form, and remaining one more carbon and 3 hydrogen, so it forms CH3. So you know, when benzene containing the CH3, it is a toluene, it is one of the chemical compound. Now clear, students? So what is aromatization? Very simple. Aromatization is nothing but there is a formation of benzene ring by taking some alkanes. Okay, so here I have taken the N-hexane. So N-hexane you can heat in presence of some catalyst like chromium trioxide and vanadium pentoxide. So after heating, so what happened, there is a bond formation takes place and simply we will get what? Benzene ring. Okay, now clear, students? So this is what aromatization reaction. So before that you just take the screenshot, students. So then we will discuss the another important reaction. Okay, so I will give you 10 seconds, you just take the screenshot. Okay, students, see this next reaction. So I am taking the reaction with steam. This is the sixth reaction. So reaction with steam. So when methane reacts with steam, steam means it contains the water, H2O. Okay, so very simple. Steam is nothing but what? Water. So we just heat at 1275 Kelvin temperature in the presence of nickel. So here I am using the catalyst nickel. So when this methane is reacted with the steam in the presence of nickel as a catalyst, we have to heat at 1275 Kelvin temperature. So obviously what happens, students? So during that process, so hydrogen gas is involved. So obviously carbon should be there, oxygen should be there. So carbon and oxygen will come together and it forms the carbon monoxide gas. So carbon monoxide gas also coming and dihydrogen is prepared. Okay, students, 3H2 will form. So this is very important method to prepare the dihydrogen. So it is one of the industrial method to prepare the dihydrogens. Now clear, students? In most of the pharma as well as chemical industry, they need to prepare the hydrogen gas. So they can use this method to prepare the dihydrogen. So very simple method, students. So first of all, they can take the methane gas, okay, and they can react with the steam. Steam is nothing but water. Just they can combine together and they can add the nickel catalyst and they just heat it. Okay, up to 1275 Kelvin temperature. So after heating, what happens, students? Carbon monoxide gas is released and hydrogen gas will form. So that is a dihydrogen. So this is what reaction with steam. Okay, students, the next reaction we will discuss now. That is a pyrolysis. Okay, students. So what is meant by pyrolysis? So this is a very important concept. Okay, so first of all we see what is meant by pyrolysis. So pyrolysis means breakdown, or we can say it is a cracking. Okay, so what is the meaning of pyrolysis? Pyrolysis means breakdown or cracking. So simply, so there is a pyrolysis means there is a decomposition there is a cracking. Okay, so very simple. In pyrolysis we can using the higher alkanes. So when we can heat that higher alkanes, that higher alkane convert into the smaller fragment of alkene, sometimes hydrogen also release. Okay, that is a pyrolysis. So very simple. See the definition I am written here. So there is a decomposition of higher alkanes. So you can take the higher alkanes. So there is a decomposition of higher alkanes into smaller fragment. Means small fragment is what? Suppose if you take the hexane. Okay, so that hexane convert into the butane and ethane. Okay, butane or ethane. So in two fragments they will form. So decomposition of higher alkanes into smaller fragment on strong heating in the absence of air. Okay, students. So there is in absence of air this reaction is carried. This is very specific reaction. So in absence of air is called what? Pyrolysis. Now clear? So what is the pyrolysis? The decomposition of higher alkanes into the smaller fragments on strong heating in the absence of air, okay, is called pyrolysis. Okay, and pyrolysis is nothing but what? Cracking. So pyrolysis is a free radical reaction. Okay, students, very simple. So this pyrolysis terms we can using in the petroleum industry. So you remember this is very important concept. So in petroleum refining industry we can use this concept pyrolysis. Okay, just we check the reactions how pyrolysis takes place. So here I have taken the methane gas CH4. So when we can heat this methane, so here already told we can heat at higher temperatures. We can heat at 1000 degrees Celsius. So when methane we can heat, so it breaks down into the smaller fragments like carbon and H2. Okay, see, in methane how many carbon? Only one carbon and 4 hydrogens. One carbon is released, smaller fragment, and 2 H2 is how many hydrogen? 4 hydrogens. So easily we can separate the carbon and 2 hydrogens, dihydrogen also we can prepare here. So see the other reaction students. So here I have taken the C2H6. C2H6 we know. So it is what? Ethane. So ethane when we can heat at 450 degree Kelvin temperatures. 450 degrees Celsius. So what happens? So after that heating, so it can break down into two smaller fragments. So obviously in this ethane, so the 2 hydrogens, dihydrogen is released and it forms the C2H4 and H2. So just check it. C2H6 is there. So from this C2H6, 2 hydrogen is removed. Okay, it can release the 2 hydrogen. Yes, dihydrogen is formed and C2H4 is what? It is what? Ethene, double bonded compounded form. Okay. So now clear. So in pyrolysis we can prepare also alkene as well as alkane and hydrogen gas also form. See the one more important reaction. So just we can check another example. Here I am taken the hexane C6H14. Okay. So in there is a 3 possibility in this reaction students. So when this N-hexane can heat at 773 Kelvin temperature. So the first possibility, the first reaction is what? So what we will get here? So when this N-hexane we can heat, so it decomposes into the smaller fragment like this. So it forms the hexene. C6H12 is what? Hexene. Okay, and H2. This 2 hydrogen is released from this. H2 will remove and it get hexene and dihydrogen. Okay, this is the first possibility. So second possibility is what? So this hexane, so after decomposition it form the 2 fragment like this. One is a butane. Okay. Butane and another one is a ethane. Okay, C4H8 is what? Butane. So double bonded compound is there, and C2H6 is what? Ethane. Just take the carbon structure C4H8 and C2H6. So C4 and C2 C6, and then H8 and H6 H14. So the same carbon and same hydrogen should be there. C4H8 it forms the butane and ethane. So these 2 fragments after breaking this hexane, so the possibility it form the butane as well as ethane. Okay. So another possibility students. So when this hexane we can heat at same temperature, so we get what? Propene C3H6 means what? Propene. Then ethane. Ethane. Propene, ethane, and methane gas. Okay. So there is a 3 possibilities here. So C3H6, C2, and C. Is how many carbons total? 6 carbons. Hydrogen also same, just check it. Okay students, so this is what pyrolysis. So generally in pyrolysis what happens exactly? Now clear. So in pyrolysis there is a breakdown of the higher alkane into the smaller fragment like alkene and dihydrogen gas. Okay, so very simple. So higher alkane break down into the smaller species like alkene, alkene or hydrogens. So this is a very important term in a petroleum industry. Okay students, so all of you understand this concept. So in the next class we will discuss the another chemical reaction. So before that you just take the screenshot, okay, and write down the notes. We will discuss the another reaction in next class. Okay, you just take the screenshot.